All right, this is the last video tutorial of Lab 5, and in this tutorial I'm going to show you how to find a fading supernova in a supernova dataset. I'm going to share my screen. Okay, we are now looking at the finder chart that's included in the lab, and this is from one of the images in your supernova dataset. A supernova, you never know when they're going to occur or where they're going to occur, and that's why we're using archival data for this particular exercise instead of going out and trying to collect fresh data. It can be a long wait, and you never know exactly where in the sky it's going to occur. But this data set was collected with the Prompt telescopes, and that's one of the things that Prompt is good at, finding these supernovae. In a galaxy our size, you may have to wait 100 years for a supernova to go off. But what the Prompt telescopes do is they image hundreds of galaxies every night. By imaging galaxy after galaxy after galaxy, we're more likely to come across one in which a supernova is currently going off. And we discover supernovae maybe every couple weeks using the telescopes, and we're one of the leading discoverers of supernovae in the southern hemisphere. So you'll be using one of these data sets. Now in the finder chart, you can see the galaxy, and you can see which star we've marked to be the reference star. The question is, which star, which point of light in this image is the supernova? We have not marked that, and in this exercise, you're going to find out which one is the supernova using the same technique that we had to find it out, to figure it out, and that's a process called image differencing. So let's move over to Afterglow. Now I'm going to demonstrate this, but I'm going to demonstrate it with a different supernova data set. So I don't, in the process of explaining it, show you which one is the supernova. I want you to find it in your data set yourself. But I'll find it in this other data set collected with Prompt. So we have a collection of images numbered 20 through 54, collected over the course of a couple months. The early images were when the supernova was bright, and then it faded away. So it should be a bright point of light in the first image, and then a faint point of light in the last image. But there's so many points of light, you won't be able to tell, usually just by looking at the images. What we have to do is something called image differencing. We take the first image, the last image, we align them, and then we subtract them. And as long as the count levels are similar between the two images, everything will cancel out. The galaxy will cancel out, the stars will cancel out. The only thing that won't fully cancel out is the supernova, because it's brighter in the first image, fainter in the last image, and so when we subtract them, some of that light will be left over, and that will let us know which part of the image, which star is the supernova. Okay, so first we have to align the two images. So we'll go over to the aligner tool here and select images to align. We'll select the first one and the last one. And we want it set to astrometric. Overwrite files, we want that checked, and we're going to submit it. Okay, the job has been processed. The first and the last images have been aligned. Now we're going to go to this tab called the Image Calculator, and we want to make sure it's in simple mode and image mode. And then we'll select the first image here. We'll select subtraction, and we'll select the last image here. And let's not overwrite the files. Let's create a new file. I'm going to submit that job. Okay, it's now created the difference image. If we scroll down, we'll see there's an additional file here. If we load it in. Okay, so what are we looking at? So this is the differenced image, and you can see the edges are a little bit messed up, and that's because the two images were not perfectly aligned to begin with. So the region here is the overlap region. That's the part that we should concern ourselves with. If we look in here, it's mostly canceled out. The galaxy is gone. Most of the stars are gone, but there are still a few points of light. Some of the stars didn't cancel out perfectly. If I zoom in here, you can see there's a star and then a subtraction, but the alignment wasn't quite perfect, or the star was blurrier in one image than the other, so it didn't cancel out perfectly. But that's clearly not the supernova. And then we also have individual pixels. That's too small to be a star. That could be a cosmic ray hit on the CCD detector, or just a bad pixel in the detector. We're looking for something broader. It's not a single pixel, not an incomplete cancellation. So that right there is our supernova. And we're going to use this in the difference image to find it in the original image. So to do that, you come over here to the gear symbol. We're going to split the screen. We're going to sync the orientations. So we have the difference image over here. Let's come back to the file list, and down here in the second window, let's load in the original image. You see these two images are synced, they move together, and we can use what we found in the difference image to identify it in the first image in our data set. So this right here is the supernova. Let's go over to the marker tool. Let's turn centroid clicks on. We're going to mark it. If you click on it again, you can give it a label, such as SN for supernova. And then we just want to frame it to save as a file. And it's nice to get the galaxy in there. Since our window is very horizontal, I think what I'll do is I'll go back to the display tab and I'll rotate it, and then I'll come back to the marker tab. That way I can expand it out and use this horizontal space, getting the supernova in over here on the left, and the galaxy and a few other stars as well. And then we're just going to save the difference image and save the first image in our data set with the supernova marked. Okay, that's it for this tutorial.